Hello everyone, welcome back to my channel. Today, we're diving into the world of algorithms and computational efficiency, and we're going to demystify the concept of big O notation. What is big O notation? Big O notation is a mathematical notation used in computer science to describe the performance or efficiency of an algorithm. It helps us analyze and compare algorithms based on how they scale with input size. In simple terms, it answers the question, how does the runtime of an algorithm grow as the input size increases? Why does big O matter? Understanding big O notation is crucial because it allows us to make informed decisions when choosing algorithms for different tasks. It helps us identify the best algorithm for a specific problem, considering factors like time complexity and space complexity. Big O notation provides a common language for discussing and comparing algorithm efficiency. Common big O notations. Let's take a look at some common big O notations and what they represent. O of 1 is constant time. The algorithm's runtime remains constant, regardless of input size. Example, accessing an element in an array by index. O of log n is logarithmic time. The runtime grows slowly as the input size increases. Example is binary search. O of n is linear time. The runtime grows proportionally with the input size. Example, iterating through an array. O of n square is quadratic time. The runtime grows with the square of the input size. Example, nested loops. O of 2 power n is exponential time. The runtime grows exponentially with the input size. Example, recursive algorithms without memoization. To illustrate big O notation, let's consider an example using linear time complexity O of n. Imagine we have an unsorted list of numbers and we want to find a specific number in the list. In the worst case scenario, we might have to go through every element one by one until we find the number. The time it takes to complete this task grows linearly with the size of the list. Big O notation is a powerful tool for assessing the efficiency of algorithms and making informed decisions in programming. In upcoming videos, we'll explore more big O examples and dive deeper into algorithm analysis. So be sure to subscribe and stay tuned.